Alright, in this video we're going to be solving equations with variables on both sides of the equal sign. Now, one of the things that I would encourage you to do if you're in my classes is to look at your flow chart that we've given you in class. That's going to give you step-by-step how-to instructions to get through these. Some of the steps that I'll go through with these problems might vary from that just a little bit depending on the problem. But for the most part, it's the way that you're going to want to get things done. And remember, we are solving equations here. So what you're going to want to do is to get the variable on one side of the equal sign or the other. Doesn't matter left or right, though I know most of you like to keep it on the left. And we want to get it alone and then all of the constants on the other side. So let's take a look. We'll do a few of these problems here together so that way you can see different problem types, some that are easier, some that are harder, and we'll work from there. So number one, we've got 5x subtract 6 is equal to 2x subtract 18. In this case, what I would recommend that you do is look to see if you have any sort of simplifying that you can do up front. Notice in this case we have unlike terms on both sides, so not a lot going on there. Next thing I would recommend you do is to get rid of any grouping symbols. Notice in this case, no grouping symbols, so we're good there. After that, I would get rid of any constants first. So in this case, I'm going to try and keep x on the left side. Notice here's a constant. I've got this negative 6. So to get rid of that, I'm going to add 6 to both sides of the equal sign. So I'm going to add 6 to the left-hand side here, and I'm going to add 6 to the right. Notice, these are like terms, so they will go together. I can't add this 6 to this 2x. That does not work. So negative 6 plus positive 6, that zeroes out. So we end up with 5x equals, because notice 5x is the only thing left, 5x equals 2x. Now I've got a negative 18 plus 6, so I know my answer is going to be negative, and if I take 6 from 18, we'll get 12, so a negative 12 is the result. Now, I want to try and get the variables together. All right, notice I've got the 2x on the one side, 5x on the other. Let's move the 2x and get it out of the way. To get rid of a positive 2, again, positive 2x, that whole term, not just the 2, but the positive 2x. We're going to subtract 2x from both sides. Okay, 2 minus 2 zeroes out. 0 minus 12 is just a negative 12, so that was easy. 5 minus 2 is 3, so 3x. We're nearly done. Now, I've got 3 times x equals negative 12, so we can do this a couple ways. Since it's multiplication, we can simply undo by division, or we can sit here and think, well, what times 3 would give me a negative 12? In either case, whether you go ahead and write out the division or sit there and ponder it in your head, you're going to find that x in this case is equal to negative 4. Now notice in my directions here with this problem, and this is going to be true I think for most math teachers, you must show work to get credit. So what I've got here is all the work that you need to do. Notice I was able to fit it in the space provided, and guys and gals, if it doesn't fit, go to the back of your page where it's blank, grab another sheet of paper, but make sure that you do show your work. All right. Again, you've got a lot going on here. You don't want to try and do it all in your head. All right, so let's try another one. Let's go down here to number 3, just because we've got negatives here, and a lot of times people panic over that. So again, the first thing I'm going to do is try and figure out which side of the equation I'm going to get x to go on. And this one I figured I'd leave it on the left. This time I'm going to want to send it to the right. So I'm going to try and get this x by itself. So I'm going to get rid of this constant first. So it's a negative 6. I'm going to add 6 to both sides. Doesn't look like a 6. There we go. So when we rewrite it, we'll have a negative 8x plus 11 equals our negative 7x remains. And remember, negative 6 plus 6 zeroes out, nothing's left. From here, I'm going to try and get the x's together. Now this is going to show you why I want x to be on the right-hand side in this case and not the left. And of course the bells just keep ringing in this building. So if I get rid of this negative 8x, to do that, I'm going to have to add 8x. And notice what we end up with. Negative 8 plus 8 zeroes out, who cares? That's 11 equals positive 8 plus a negative 7 is 1x. So notice x ended up being positive, which is a good thing. We don't want negative x's. That just makes a hassle for us. And notice we're also done. We don't have to do any last-minute division of a negative 1 or multiply by negative 1 to get rid of anything. So while your flowchart will get you through things, it shifts everything to the left. Sometimes you're going to have to be mindful and think, well, what could I shift to the right so that way things end up being positive? So in this case, x will equal 11. And we get to an answer a little bit quicker than just trying to shift everything to the left all the time. All right, well, let's ramp it up a notch. You'll notice on the page here that I'm using for just some sample problems, number 11 deals with decimals. Number 5 deals in fractions. A lot of times when people see things like this, oh, here we go again, number 6 and number 7, fractions and decimals. People panic, they're not sure what to do with it, they like working with whole numbers better. Let me show you a couple of tricks to be able to, to get through this. Let's start with decimals. If decimals are bothering you, all right, well notice in this case I've got tenths, 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 and tenths. Well, if you don't want to work with decimals, that's fine. You don't have to. We're going to multiply by powers of 10 to move the decimal over. In this case, I'm going to multiply everything by 10. Now, the problem with this method is that you're going to get really big numbers. They'll be positive, they'll be whole, they might be negative, but they're all going to be big. So in this case, 10 times 15.3 is 153. Excuse me. Subtract 8.5 times 10, 85. 3.4 times 10, 34. 15 3/10, 153. So notice we can solve this problem exactly the same way as we solved our other two. It's just that our numbers are going to be larger. In this case, I'd probably leave the variable on the left side. So subtract 34m from both sides and then add the 85 to both sides. So let's go ahead and do that real quick. I'm going to get rid of the 85 first. So let's add 85 to both sides. So let's see here. We'll have what is this? 153m equals 34. There it goes. Plus, let's see here. We'll get an 8. Oh, let's see, a 3 and a 2. So 238, something to that effect. Now we're going to go through and get rid of this 34. So in this case, we're going to subtract 34m from both sides. Notice we are running out of space. If this happens to you, use a separate sheet of paper. Negative 34m, and let's see what happens. So our 238, make sure that looks like a 3, don't want to misread it, equals, and let's see what happens. Let's see, we'll have 4, 9, and notice the m's don't cancel. I've seen a lot of people do this when they're subtracting, let's say m minus m is 0. The m is just the term that sits there, we don't get rid of it. Let's see, 1 and 1, so 119, and then we'll go from there. So we'll do our work over here. 119m equals 200, daggone it, 238. Helps if I can write. Now, again, you can solve this a couple of different ways depending on what you want to do. You can think, well, what times 119 is going to get me to 238? And if you can do that in your head, bully for you. If not, then what you're going to want to do is undo that division by multiplication. And you'll just simply divide it out. So if you need to use a calculator or the like, you're welcome to do so. Again, if you can sit there and do it in your head, you're welcome to do that as well. But in the end, you just get a very simple answer of 2. All right, so all that work for something very simple. And again, if you don't like the decimals, multiply by 10. If all of these were, say, in the hundreds position, so you had 2 decimal spots over, well, then multiply everything by 100. Whatever the case would be to get to whole numbers and then work from there. But notice you are working with some pretty large values here, so it's entirely up to you. Let's jump down here to problems like number 5 and number 6. With fractions, you have options. One option is just simply find a common denominator and work with fractions. So in this case, if I wanted to make this into tenths, because notice this would be our common denominator, I'd have 5 tenths, because 5 tenths is 1/2, and then we could work that way. There is another option. Some people like to make them into decimals. In this case, halves and tenths work well as decimals, but look down here. Now I've got thirds and sixths. Those don't translate to decimals well. As a matter of fact, they don't translate to decimals at all. So what I would recommend in cases like this, if you want an easier way, without having to deal with fractions or having to deal with decimals and start multiplying by 10 again, go ahead and find your common denominator. So in this case, my common denominator would be 10. And what you can do is multiply everything by 10. Okay. If we look down here, we've got 3s, let's see, 4s, 6s. So a common denominator here would be what? 12. Multiply everything by 12. Now, watch what happens here as I start multiplying all this out. Well, let's start with 6, just because a lot of people are going to struggle there. We'll head back up to 5. If I multiply 12 into 1/3, I'd get 12 over 3. 12 times 1. 12 over 3 is 4, so in this case, negative 4x. All right. Here, 12 times 3 is 36. Divide by 4 is 9. All right. 12 times 1 is 12. 12 divided by 4 is 3. All right. 12 times 1, that's over 6 is 2. So there, I've taken this rather nasty looking problem, found a common denominator, and just multiplied everything through. So now I've got a negative 4x plus 9 equals 3x plus 2. That's really no different than the problem we worked up here in, say, number 1 or number 3. Very, very simple. In this case, I would move our x's to the right because we'll be adding 4x to get that 7x. And I'll do this here without my work just to get through it. We'll subtract 2. Once we divide, we find x is 1. So again, this really, really complicated looking problem to get a very, very simple answer. And again, the way to get around it is to multiply everything, every term, by that common denominator. Now, let's go look back at number 5. Number 5 is a little different in that we've got mixed numbers going on here. So if we wanted to change those out real quick into impropers, we would take 9 times 2, which is 18, plus 1 is 19. So 19 over 2x equals 10 times 5 is 50, plus 7 is 57, so a negative 57 over 10x plus 152. And remember, we said we were going to multiply all this by 10. Well, watch what happens. When we multiply, let's see, what is this, 19 over 2. 19 times 10 is 190, divided by 2 is 95. There it is, I can't think today. X equals 10 over 10, well, that simplifies to just 1, so negative 57. Again, or you could say 10 times 57 is 570, divided by 10 is still 57, so negative in this case. And then 10 times our 152 is 1,520. So there, again, we've gotten some larger numbers here, but notice, no more fractions, no decimals, whole numbers only, and we can work from there. So if I take 95 and we add our 57x there, because we'll add to both sides, we get 152x equals 1,520 divided out. We'll see that we get 10. So again, these problems really aren't all that complicated. It's just how do you want to work through them. If they're whole numbers, just use your flowchart. It's going to make your life easier. If you have decimals, multiply everything by 10, every term by 10 or every term by 100, whatever it takes to make it so that you don't have a decimal. Fractions, multiply everything by your common denominator, and then you're going to end up with nice whole numbers. So for example, even here if we've got a fraction, one way to work through number 14 is to simply say, great, I'm going to multiply everything by 3 because that would be my common denominator. Why are the bells ringing all the time today? So 3 times 2, so that would be 6y. 3 divided by 3 is 1, so just 1y. And then 3 times 5, well, that's 15. So again, the values have all gone up, but now you're dealing with nice whole numbers. We can subtract 1y from both sides. We end up with 5y equals 15. Divide everything by 5, and we get a 3. So again, fractions, find a common denominator, just multiply everything by it. Decimals, just multiply by 10, 100,000, whatever it takes to get rid of the decimals. Whole numbers, well, just follow your flowchart and you'll be fine. Again, if you need help, please swing by in the mornings and see me. Otherwise, I assume you're good to go. Thanks, guys.